didn't mean it.
Yeah, yeah, I know.
No, I know.
Let's jump into this automotive electronic test 4. A wiring diagram illustrates 3 wires that are joined together at C215. Technician A says the wires are connected together at C215. Technician B says the 3 wires are part of circuit 215. Who is correct about that?
Hey,
Now, I do not like the way that that question is worded. They're not joined together, are they? They're going through different cavities in C215. Just like I showed you guys, this right here, let's say this was connector C215. These 3 wires right here are all going through this connector, but they're not joined together, right? They're 3 separate circuits. Now, that's a poorly worded question. I don't know who wrote it, but I'm going to have to talk to him about that. All right.
So, put this way.
Put A. A is the right answer, but I'm telling you, I don't like the way that wires, if they're spliced, they would be spliced at S215. But you might notice this connector here is A, B, C, D, E. This is the GM WeatherPack connector. Which of the following is not used to protect a circuit from too much current flow? Fuses, fusible links, bus bars, or circuit breakers? What's a bus bar?
I don't know.
No, you've seen them, you just didn't know what you were looking at. All right, you're going to see a ground. Think of yourself reverse engineering, right? I've got a ground and I want it to go out and feed a lot of things. A lot of stuff on that car I want to feed with a ground. All right, and so what I'm going to do is I'm going to make a little thing that looks like a, I'm going to say it looks like a comb or something like that. This is a form of bus bar. And I'm going to plug my wire into that one, and then I'm going to let this one go out to everything else that's got to be grounded. You seen those before? That's a bus bar. Everything, this is a metal bar. This is hooked to just one of them, and this feeds everything else that ground is supposed to feed. You're going to see those on vehicles. A lot of the times when you see them, they'll be sort of a sealed up looking thing, like this right here. And you'll see a bunch of wires going into that same little block. That's a bus bar. Got it? That's how that works. An inoperative, but a bus bar doesn't protect the circuit, it just spider webs it out to other ones, and so that's B is the right answer to that one. Number 3, an inoperative radiator fan needs to be repaired. Technician A says a single circuit type wiring diagram would be the simplest diagram to use. Technician B says a component locator, bless you. Technician B says a component locator will probably be needed to repair this circuit. Both of those people are right. You're probably going to need a component locator, just like I was showing you guys a minute ago on the overhead here. In order to find a problem, you're going to have to determine what circuit the problem is on. And you're also going to have to determine which connectors are on that circuit. You're going to have to find out where those connectors are. You're going to have to find out which cavities in those connectors the circuit in question goes through. And then you're going to use the connectors to break the circuit up in pieces so that you can tell, like if you've got a wire harness short or something like that. Now there's how many of you guys know the difference between a short and an open? A short's when 2 wires are touching each other or a wire's touching ground somewhere. An open is when the wire's been cut in 2. Got me? Like for instance, I used to see sometimes where people would, whenever they would get a brand new vehicle, like a truck or whatever, and they would want to put their own running boards on there. And so they would take these big old lag screws and they'd knock a hole in it with a punch, and they'd run those screws in there and they'd go right into a wire harness. And so the wire harness, that screw goes cutting into that wire harness with those sharp lag screw threads, and they dig into the wires and they short things out, right? And so then you've got a bunch of stuff that doesn't work. You hear me? That's what happens there. And so that's a short. But what if somebody actually managed to put a wire harness over there too close to a belt, and that belt goes wheeling around there like a saw, and it cuts that wire in 2. And now you've got something that doesn't work because the wire's in 2 pieces. That is an open. So sometimes when people jiggle something and the operation changes when they jiggle it, they'll say it's got a short in it, but it's only a short if you've got 2 things touching. If you've got things that aren't touching, it's, you know, like if you open this, if you turn off a switch, you've created an open circuit, right? What's the best place to find the location of a blower relay?
A.
Actually, B, component locator. Of course, that's a sort of that's, I don't really like that question either, because your wiring, let's say that your wiring diagram was a book. Let's say that you had a book. It was your wiring diagram, right? Within that book, you're going to find your component locator, typically. That's the way that works. So if you've got paper books, the wiring diagram is going to have a bunch of stuff on it, so you're not totally wrong, but the part of the book you'd look would be the component locator. In the same wiring diagram manual, you're also going to find locations and shapes of connectors and locations of grounds. Now, what if I told you that every time I turned on my headlights, my windshield wipers came on? Give me a couple of possibilities. Somebody think.
Might be the wrong connector.
Possibly. That's what I was telling you about last week, but in this particular case, it's something different. I was telling you about a Taurus where they had to hook the windshield washer wired to the cornering lamp and the cornering lamp to the windshield washer. Now that, that's what you were remembering, and that was good. But what if nobody has hooked anything up backwards, but you fire it up?
Put the fuse on.
Well, no, that wouldn't do it. What about a bad ground? Let's say your wipers work just fine until you turn on your headlights and then they quit working. That means that the wipers were getting a ground through the bulbs on the headlights. And when you turned on the headlights, they went out. I mean, that's just, you usually won't find one wired that way. But if you turn on one component and other ones light up or go away, that typically means you got a loose ground. That's what that means typically. Let's see, Technician A says wiring diagrams give specific circuit information in detail. Technician B says a wiring diagram will help you find the fault. Both of those guys are right. You better get good at reading wiring diagrams. And what gets me is, this is what amazes me. I'll have one student that will find a particular connector or circuit or component in a wiring schematic, and he'll go and they'll find out. And then I have another other person that will go to the same computer, same program, same vehicle, and they'll say, I can't find it. But you go in there and you click enough and look around. If you want to find it, you'll find it, right? You have to be a detective. You got to have old Betsy, your test light with you, or your meter and all this kind of stuff, right? All right. How are fuses rated?
Resistance.
A,
Resistance. Come on, man.
by current.
Good answer. Good answer. You read the chapter, didn't you? No, you just smart, ain't you? All right. Technician A says 2 connectors with the same number are physically the same connector. Technician B says 2 connectors are drawn apart, so the drawing is easier to read. C. Here's the thing, and I can show you on a schematic up on the board. You may have a connector over here that says C217, and you got some wires, whatever. And then you may have another one over here that says C217. Both of those are the same connector, but that doesn't mean they're 2 different connectors that are numbered the same. It means they couldn't draw it with just one connector because of where the way the stuff was laid out. All right. And you're going to see that too. Know those numbers. Know what those numbers mean. What are we reading? What do the numbers mean?
C217.
If we've got numbers next to it, and I got to make sure you guys get this burned in. Okay, over here, I've got a 217. Over here, I've got a 0.5. Right above that, I've got a B. What do I know about all this right now? No. It's some color that starts with B, depending on which manufacturer you're using. This is the size of your wire in millimeters, 1/2 millimeter, and this right here is a circuit number. Circuit number, wire size, color. Got that? And if it's black, light blue, it's going to have a black blue stripe. Black being the dominant color, blue, whatever. Remember, on your Asian cars, L will be blue sometimes. So if you see an L, that's blue. They'll have BN, BK, and L on some of them. Now, that's only on Asian cars. They don't typically have that on these other cars. Now, right here, I've got this right here, and that is C201. That's a connector. You got to be able to find where that is. You need to find, and this C201, if it's got, remember, if it's got a, let's say if it says C201, and then it's got a dot over here, and there's another wire like that. Once again, that means the same connector shell, both these wires go through it. Burn that in, you know. You're not just trying to get the test off your board and all that kind of stuff. Technician A says twisted/shielded wire carries low current and repairs to the wire must not increase the resistance of the circuit. Technician B says twisted shielded wires carry high current, repairs must not increase the resistance of the circuit. That's A. Now how would you increase resistance of the circuit? If you tie it together and you tape it, you're not really making a good repair. If you solder it and put heat shrink on it. But what's a shielded wire? Anybody know? How many of you guys have ever seen these wires? Say that again. What were you going to say?
I was going to say, windshield wipers, windshield.
No, typically a shielded wire is going to be one that carries a signal like your bus or like your crank signal. Any kind of a critical wire, you'll see two wires that are twisted together, right? And you'll see them in some cases wrapped in foil, and I'm trying to draw this. This is wrapped in foil. And coming out of that wire, you'll have a naked wire that doesn't have any insulation on it at all. It goes to a ground. And see, the wires that come out of there will be twisted wires. And they're going to go, and basically, they're drawn in a wiring schematic. They'll have a dotted cylinder looking thing. And they'll have the wires going through that, and this right here will be drawn to be grounded. That's a shielded wire. That's what it is, if you see it. When you see that, you need to know that that particular signal is so easy to disrupt. If you've got a magnetic field that's flowing across a piece of wire, it's going to create magnetic interference or actually create induced current in it. And back when Explorers first came out with this same kind of ignition system you see I've got on that board and on that engine right there, just because of the way they were, they would have the crank sensor wire running. They accidentally ran it right next to the battery cable. All right, what's going on around the battery cable? Whenever you spin it over to start it, use massive amounts of magnetism is being generated as current flows through that battery cable, and it was confusing the crank sensor signal and totally blanking it out, and the truck wouldn't start. It wasn't getting a crank signal. Was the circuit damaged? No, but you had the wire too close to the battery cable. And if you run a current carrying wire too close to the battery cable, or any heavy current carrying, you're going to cause yourself issues. On some of these vehicles, they would have us, when we had some kind of an issue with communication between modules, they'd have you to disconnect the wires from both modules, the communication wires, and put more twists in them. They'd have to have a certain amount of twists per inch in order to keep from getting interference, right? All right. Let's see. Interference on these computer circuits is really important. You can't do that. Here's another thing. Let's say you're thinking you've got some kind of electrical interference that's causing some kind of an intermittent problem. And let's say that you want to try to use every method at your disposal to find out what it is. Have you got an AM radio on your car?
Say,
Yeah, exactly. So what you're going to do is you're going to put your radio on AM, and you're going to turn it down to the lowest end of the AM scale. That's the most susceptible frequency for interference. Okay, and then you drive it along listening to that static. And when your problem happens, if you hear a big interruption in that static, you know, a big reaction to whatever happens, you know you got something electrical going under the hood that's basically creating interference. And if that radio picks it up, the computer might pick it up. Of course, they got everything pretty well now where it won't do that. But that's another way you can do it. Another trick you can do is if you've got an old TV remote from an old television, these things actually, not only do they put out an infrared, like this one here, see I got infrared that this one here will put out, but if it'll put out infrared, the older ones are also poorly shielded and they put out radio waves, right? So set your radio to the lowest end of the AM band. Let's say you're blowing a fuse. And let's say you're blowing a fuse somewhere between the headlight switch and the tail lights. You know the fuse doesn't blow until you turn on the headlights, and it's blowing your tail light fuse, so you want to find out where it is. You don't know where it is. You've determined it's not back there and it's not up here and it's somewhere in between. Okay, so what I'm going to do then is I'm going to take a wire and I'm going to connect it from the antenna on my radio, if I can get to the antenna. Some of them have actually got it in the glass or whatever. And I'm going to hook that antenna wire into the radio, and I'm going to put the radio on the low end of the AM band, right? Turn on the radio so you can hear it play. And then I'm going to go follow the place. You remember I showed you a while ago where it'll show you how the wire harness is routed? I'm going to follow the wire harness that I know is going to those lights, and I'm going to start mashing the button on my remote using it. And when I get to the place where the body of the car is actually got the wire shorted against it, the body of the car is going to pick up that poorly shielded radio signal out of the old remote, and it's going to cause interference. So you can actually go to a place where a short is like that. Are your eyes glazing over? Is that an interesting thing I just told you? Were you paying attention?
The AM, that radio.
The low end of the AM band, go all the way to the level, like the 700, you know, it's like, you know, the AM's in kilohertz and FM's in megahertz. So it's basically a lot lower. In Vietnam, they would actually have an AM receiver on their jets, and if all of this squawking stuff meant that they'd been painted by radar and there was a surface-to-air missile on the way, and they could try to dodge it. But that was it's like a radar, you know, thing. Of course, now they got different ways of doing that. Technician A says stranded wire has more resistance than solid wire. Technician B says there's more surface area exposed in a stranded wire due to electron flow. That's B only. A bunch of little wires has got more surface area. Why are we concerned about surface area? Because the electrons flow on the surface. The electrons do not flow inside the middle of the wire, they just flow on the outside, right? So if you got more surface area, you got better electron flow. That's why one of the reasons, among others, that welding lead and battery cable has got a lot of wires instead of just having one thick piece of copper. Another reason you don't have a thick piece of copper is because it's bad to bend and break. Technician A says if a fuse burns out when a switch is turned on, a short circuit is present before the switch. Is that true? Meaning before the switch, being between the fuse and the switch. All right. Technician B says if a fuse burns out when a switch is turned on, a short circuit is present after the switch. That's B only. A switch is drawn on a wiring diagram with NC printed beside it. What does this indicate?
Static.
It will be normally closed with a vehicle running. Is that right? Everybody like that? Good answer. NC means normally closed. NO means normally open. What does COM stand for? COM. Common? Common, not computer. Please. All right. All right, let me see. And I was thinking about a relay when I said that. What does a dotted line between connectors indicate?
D.
The connectors are physically the same. That's true. Technician A says printed circuit boards may become etched if touched with bare hands. Technician B says printed circuit boards are simply used to, are used to simplify the wiring of circuits. What you got? What do you think?
I don't know what they mean by etched.
Huh? What now?
I don't know what they mean by etched.
Oh, you're going to have, if you get your hand on a naked piece of copper that hasn't got any kind of shielding on it at all, these acid from your fingers will have a tendency to make it get little pits in it. You know what I mean? Because you got your body pH is not, what's the neutral pH? 7 is neutral. You go down, you got acid. You go up, you got alkaline. If you go in either direction from 7, you're going to have some corrosion taking place, aren't you? It's an unbalanced condition, and it's going to start carrying ions away. So that's what it means when it's etched.
So you see that?
Yeah, basically number 13 is going to be C. Yeah, it's going to be C. Technician A says a common point is represented by a black dot on the wiring diagram. Technician B says a connector could be a common point. What do you mean by a common point?
The middle ground usually.
Let's say we got this wire going somewhere, and we got this wire going somewhere, And we're the engineer, and we've decided we want these two wires to be connected together. We're just gonna borrow a ground or some power or whatever from one of these wires and let it feed the other one. You got me? There's two ways you can do that. One way is you can splice them. Let me go ahead and do this a different way. You can splice them with this black dot is a splice. It's been wires like connected together, and you got the wires connected. All right, that's one way, right? Now the other way you can do this is where they are going through their little terminal that's in this plastic connector shell. You can hook them both together right there, can't you? You can hook them both together coming out of a connector, or you can splice them with a splice. Not complicated. All right, so number 14 is going to be Charlie. Technician A says crimping solderless connections is the best method of splicing wires. Technician B says crimping should not be used if a connection is subjected to excessive movement. That is B. Let me tell you about, there was this lady that had this 2006 Impala, and she said, I can't get my car out of park. And so I said, okay, so what do you have to do in a normal set of circumstances before you can take a vehicle out of park?
Push the brake down.
You gotta push the brake pedal, okay? Well, that's a good place to look for this problem, isn't it? So what's the first thing I do? I go back here. What are you laughing about, Quincy? Yeah, Quincy caused a big problem with a Bronco. But anyway, what you do, that's another story, ain't it, Quincy? Yeah. Anyway, so I went around there. What do I do first? What's the first thing you're gonna do if she says, I can't get my car out of park? It starts just fine, but I can't take it out of park. Quick and easy now, what you gonna do?
Push the brake down.
And
Try clearing the park.
it won't. Now what?
Hit reverse,
Sir?
press down the brake and put it in reverse.
Well, we're trying to put it in gear and it won't go in gear, right? We can't even get it out of park. We can't get it out of park. What are we gonna do?
Steer it off.
First thing I'm gonna do is see if the dadgum brake lights work.
Brake lights.
Yeah, go to the stoplight. Go to the stoplight and see if they work. What do I, if I mash the brake and the stoplights don't work, I'm a little bit closer to finding my problem, ain't I? We probably got a stoplight switch problem, right? But on this particular car, as if I remember right, I'm talking out the top of my head here, when you mash the brakes, the body computer receives a request from the brake light switch to turn on the brake lights. So you're not turning on the brake lights with a brake light switch on this 2006 Impala. You're asking the body computer to turn on the lights for you when it sees the brake light switch. Okay, so then what are we going to do? We look it up and we found out that's how it works. We know, how do we know the body computer is getting a brake light signal? Because we got brake lights, right? That ain't rocket science. So we go down here in the console and we look, and there's a little solenoid down there that is actually de-energized, or energized rather. No, it's energized whenever the body computer receives this brake signal. And it's supposed to release that little solenoid and move this little dog so you can take it out of park. Okay, well what was wrong with hers was the wires were broke right there where we went into that solenoid. And why were the wires broke? Because every time you put it in gear, you're bending those wires. The way that thing was put together at the factory. Now they don't all do that, but hers, what's going to happen? You guys have any of you guys ever broke a piece of wire with your hands? You just bend it and bend it and bend it and bend it and bend it, and in a minute it breaks, right? Well, copper's the same way. You bend it and bend it and bend it and bend it and bend it, and after a while it's in two. Now you may still have insulation that's gripping it, right? But whenever you have a situation like that, you can actually take that connector and unseat it, that little thing, out of the connector shell. When you find out, if you can stretch some wires right there, you know they're broke inside the insulation. Pull that, strip it back, and you see what I did up there? You see how I crimped that wire with that laying right next to that terminal? After I've done that, I solder it. And then I fixed it and it's back like factory again. But you gotta get it really close and tight like that so that it's not too fat to go back in the connector. That was on that particular car I was talking about. That's what we did up there. And so I ought to show that to my viewers there, right there. That's what I'm talking about, right there. That's how you do that, right? All right. Now then, okay. What I had to do to fix that was we had to fix those wires, and then she was able to put it in park again. But what did we do? Did we fix it and just let it break again? We try to do it a way so that the bending that it's done is on a bigger loop, not right there at the connector. That makes sense? Okay. Now let's keep going. We got a little bit of time here. Technician A says a wiring diagram indicates where circuits receive their voltage source and the color of the wires in the circuit. What have I been showing you guys? Technician B says wiring diagram indicates what circuits are interconnected and gives the location of electrical components. I think we can all agree that both of those guys are on target. All right, now let me go to my next little thing here. Technician A says wiring harnesses pass from the passenger compartment to the engine compartment through bulkhead connectors. That is true. There are occasionally you'll see one where it's going through a grommet or something like that. Technician B says a wire harness is a group of wires that branches out to various electrical components. That's not rocket science there. That is obviously C. Ground straps are used to provide a return path to the battery between insulated components. When I say C, I mean both A and B are right. The ground straps are used to provide a return path to the battery between insulated components, suppress electromagnetic induction, both A and B or neither A and B. Let's see. I had a motorhome, or a bunch of motorhomes that were coming in there, these F-53 chassis Ford motorhomes that would come to the dealership, and they would complain that as they drove away from a stop, the temperature gauge would go up. And then as they came to a stop, it would go back down. And whenever they built this motorhome, they knew that the engine had to be grounded to the frame in order for the gauges to work right. And so what they did is they took a piece of double aught cable and they put an eyelet on both ends of it, and it was a real short thing. It just went from the motor directly to the frame. Well, what does the engine do every time you take off? It moves a little bit, doesn't it? It torques because it's pulling against its mounts. And it kept bending the wire lug that was put on a frame until it broke it. So you didn't have a ground between the frame, which is what the body of what the instrument cluster was grounded to, and the engine. And so whenever you would take off, you would see crazy things happen on the gauges, you know. So basically all I had to do was take a braided ground strap that was very pliable, and I'd have to reground it with something, or either take a long loop of a skinnier wire to ground it like that for that purpose. And so who's blowing that horn out there? Okay, let's see. Two technicians are discussing shielded wire repair. Technician A says the shielded wire must be kept separate from the circuit wire. Technician B says there's no difference between repairing a shielded or a non-shielded wire. A is the one. You don't wrap a shielded wire up right next to a wire that's going to carry current. So I was talking about a while ago. Technician A says a wiring diagram is an excellent tool in locating circuit failures. Technician B says most cases wiring diagram is not necessary to locate circuit failures. A is right. If you just go to try to wing it to fix a wiring problem, and you're going to be most of all disappointed, and you're going to look plumb silly. Now, incidentally, this particular sheet right here, I'm going to plant a no-start bug and or no crank bug. It's basically no crank means that the starter doesn't work, and you're going to have to dig into that and find out why it won't start. And we're going to let you learn to dig into a wiring schematic. So, anybody got any questions? That's the only worksheet I'm.
What's 18?
Huh?
What's 18?
What's 18?
Yeah, the answer.
Charlie?